part of the book focuses on percents and a lot of vocabulary that goes with percents. And there's different ways to find percents. So you could use a ratio and proportion, and you could use ratio table. So we'll look at both ways, and then you pick. You just pick the way that works best for you. And if you're like a lot of people, sometimes one way works best some of the time, but then that other way could be helpful once in a while. So you want to know both ways. So let's take a look at percent. And one way is to think about like a ratio table. And so kind of follow this idea through, and you'll find that some people do this pretty comfortably, and other people kind of have to learn the skill. But would you guys agree that 100% of 25 is 25? Right? So if you understand a ratio table, you could just figure out a way to get from 100 down to the percent that you want. Like down to 10%, I would just have to divide 100 by 10 to get to 10%. Does that make sense? And so that means I would just divide this by 10. And I think this method is what kind of goes on in people's heads when they do mental math. They sort of think about it, and in their head they're able to calculate percents pretty quickly. I think when they do that, a lot of times, not everybody, but a lot of times people sort of think in chunks. And they just sort of can do this in their head. Look at, I lost the 10. But other people might do a ratio and proportion. So they might say like 10% could be the same as 10 out of 100, 10 per 100. That's what percent means, right? And you want to figure out what 10% is of 25. So it's kind of a proportion where people write the percent compared to 100. So the percent they're looking for, and set that equal to the total and the part, or the part to whole. So like when you read this problem, you're doing 10% of 25, and you understand that 10% is going to be smaller than 25, right? Does that make sense? So you're really looking for the part. So you're looking for this up here, but you know the total is 25. So some people prefer to set up a ratio and proportion. Does that make sense? And that's fine. You know, that's why we teach you different tools, is to get you to use one that is useful. And so with the ratio and proportion, we learned how to solve those different ways. One way was we got a common denominator. And one way was we just saw if you could do, like, can you just divide by a number to get from here to here? And you can divide by what? 4, right? So that means you would have to divide 10 by 4. And that's 2.5, right? So that's another way, okay? There's more ways. Go ahead, Tyson.
Would you ask us how to rate 2 different
No, I think at this point right now, especially today, we're focusing on what would help you the most.
Okay, no, I mean, like, would you ask us how to rate 2 different ways on a test?
I think that right now, I don't have an answer to that. The question is, would I ask you to do it 2 different ways on a test? I think at this point, I would say no, but if I change that, I would make sure, like, on a practice test, we talk about it.
Okay.
Because I think we've already done the different ways, right? We've worked on ratio tables and we've worked on ratio proportion. You guys have taken tests on both, and the reason we do those skills is so then you start using skills that work for you. Okay, that's the whole point of teaching you methods. Does that make sense? So one other thing about this method here, the proportion, one other way we solved it back like on our second test was we did a common denominator solving. 10 divided by 100 is equal to x over 25, but then we said another way to solve a proportion is to get the denominators to be the same. which really looks different, but it's the same as the above, because now we both have a denominator of 100, right? And so we're just saying 4 times what number is equal to 10, and using a fact family. So we're actually just focusing in on this. Does that make sense? You guys understand that? So then you would have to just say 10 divided by 4 by the fact family must be equal to x. So I'll be honest with you, my preference on simple percent problems are simple ratio tables, because I think it's quicker. That's all. And if you haven't tried them, I would suggest you try them, because once you get the idea, I think for a lot of people, this is nice and quick. That's not to say it's always the way, but for a simple percent problem, if I know my 100% of 130 is 130, then I know 10% is 13. You guys see that? And then, hang on, Casey. Therefore, 20% is 26. So all I did was, I thought, well, it's easy for me to get to here by dividing by 10. And then to get from 10 to 20%, I just times by 2. And then I found my answer. And that was my answer up there. Casey?
But we maybe did it a different way than that, like division or like times something like that.
Okay, in your head it's not enough. Tell me what's going on in your head. Let's see if we can write it down. There are other ways. So the reason I picked these 2 ways is because this book is about using ratio and proportion. So tell me your way.
65%.
Okay, let's look at 65% of 40.
I found 10%.
Yeah, so that's, okay, so absolutely. And so even though I write it like this, a lot of times I write it like this so people can follow my notes. Because if I say things like that out loud, it's hard to know where it comes from. But basically what you're doing is you're just starting with 10% and you know it's 6.5, right?
No, it's more.
Oh, of 40. I did 65. Okay. Yes. So, but thank you. You just, in your head, you're starting here. That's your starting point, which is perfectly fine. I mean, that's it. Actually, what we want you to do is, we want you to have some number sense. Okay? So then your choice is to multiply.
Yeah, I multiplied it by 6.
Yeah, and that's what I would do. I would get 60%
And then
is 24.
Yeah, and then I found 5%.
And I do the exact same thing. I get 5% by dividing in half,
2. And then I just copied that.
which is 2, because I divide this by 2. So you and I are doing the same thing. And then I would add my columns. I'd add the 60%. I was going to see if I can get rid of that. So I would add my columns, 60%, and what you're doing is you're adding 60% to 5. How did that happen? 60% to 5%, and you get 26. So you have to show it to me somehow. So if your work looks different, where you do 10% equals 4, and 60% equals 24, and 5% equals 2, and 65% equals 26. That's sufficient, okay? But I think for me as a teacher, showing out where everything comes from can help more people. Does that make sense? Raise your hand if you understand how to do these so far. Okay. So the last one 12%. How many people do something like the ratio table or what Casey's doing, which is a ratio table kind of in your head, versus setting up a ratio and proportion and solving for X? Okay, let's do that. Raise your hand if you set up a ratio and proportion and solve for X. Okay, not a lot. Raise your hand if you do a ratio table of sorts somehow, because it's more like normal common sense. Okay, I just wanted to know like where I stand, like communicating with you guys. So for this one, my total is 60. And so 100%, I always just write that down, 100% of my total is my total. That's why I write that. It gives me a starting point and it kind of warms my brain up. And so then I write 10% of 60 is 6. Does that make sense? Now you could get to 1% and double it, or you could get to 2%. I know that you can all get to 2% because we did it up, well, we haven't done it up there, but we've done dividing by, I guess we could go to 2%, divide by 5, but when you look at that, it's a little, like, weirder, right? Dividing 6 by 5. So instead of doing that, what I like to do sometimes is I just go to 1% because that's easier to look at, right? If I'm going from here, I just divided by 10. So I went from 100 to 10. Now if I go from 10 to 1, I just divide by 10 again. Just getting to 1% is useful because then you can use it for everything. Does that make sense? And so if I divide this, I did divide this by 10. And now if I divide this by 10, I just get like 0.6. You can think of it like in terms of money, 60 point, 0.6 or 0.60, same thing, right? And so, so then I need to get 2%. So I just double. 1.2, 1.20, depending on the case. If it was a money situation, we were talking about tax, we want that second decimal. Because money almost goes in 2 decimal places. Does that make sense? So then I've got 60, I've got 10%, so I'm gonna take, I know 10% is 6, and I know 2% is $1.20, so then I could do 12%. And I would add my columns, it'd be $7.20 if it were money, or just 7.2 if it's a number, and that's your final answer. Make sense? Okay, so this is just a couple questions for you guys. If you make a commission at a retail store, like if you have a job, do you know what that means? No, okay. Because in the reading, there's vocabulary. One of the newer vocabulary words is commission. Does anybody have a parent that's a realtor? Anybody's parents sell real estate? Anybody have a parent that works at a car dealership? So, realtors are they sell houses, right? People in certain businesses, the way they make their money is by selling things. So like, even at a place like Nordstrom's, some of those big shopping stores, you get money if you sell things. So like, for example, you could be at a store selling a house. So you sell a house around here, houses can be pretty expensive. So we'll go with a modest house in Louisville, $400,000. Okay, so when a person sells a house, how they get paid is they get a percentage of the house sale. So like if they sell a $400,000 house, they might get a 3% commission. So if your house sells for $400,000, and that's the whole selling price. I'm sort of simplifying this a little bit, but just for the idea, 10% of that would be $40,000, right? So 1% is $4,000, right? So I don't know much about real estate commission, but I don't like know the percentages. I probably should have looked into that. But 3% is $12,000. Do you see that? So sometimes people in real estate don't sell a lot of houses, but they sell them, you know, they don't sell them every day. It takes a long time to sell a house. So they make money like that. They make a commission. And then the rest of the money goes to the people that sold the house. So like if they help somebody sell a house, maybe the people get $400,000, and then they have to take 12,000 of it out and give it to the person that helped them. They also have to take other things out and give it to the people. But the commission is like a little percentage of the whole price. So like if you're one of those realtors that only sell really expensive houses, like $1 million homes, you don't sell very many a year, but you make a lot on a house. But if you don't make sales, you don't make a lot of money. So like sometimes what happens is in the spring, people will sell a lot of houses and they'll make more money, and then they don't sell very much in the winter and they have to budget their money all year. Okay, so that's kind of what a commission is. Does that make sense? Okay. So your type of problem, which you guys are going to work out in a minute, comes kind of like this. It says if your commission is 15%, that means whenever you sell something, you get 15% of it. Okay? And you made $20 on that commission. So your commission was $20. It was like that $12,000. The question is, what was the price of the item? So now we don't know the 100%. What do we know? The 15, and we want to find the 100, right? So the percent now that we know that 15% of some number, which we don't know the total, but 15% of some number is $20. So right now our total's $20 because that's 15% of it. We want to know what is 100%. What was the actual selling price? What's a way to do that, Soham?
You could divide it by 10 and times it by 100.
You could divide by 10 and times by 100. Let's look at that, see who likes that. There's other ways. So that would be 1.5, right? And that would be 2. And then you now have 2%, right?
Oh yeah.
So what do you want to times by?
Oh, I meant 50.
By 50, yeah. And look at how I didn't catch your mistake until I started writing it down, which is why I always like you guys to write things out, because your brain and your hand, when your hand's writing, your brain is processing more. So now I'm at 100%.
No, it's 100 total.
Oh, I messed up. Yes, you're right. So that way is not going to work so well. It's my mistake. How about if we tried to get this to 5? Yeah, I mixed up my labels. Wasn't being very careful. So how about if I divide by 3? That would be 5, right? And this would be 6. Let's leave it at 6 2/3 for a minute. Okay? Then you would times by 20, right? Or you could double to get to 10. Which is easier? Doubling, so 10. So this would be 12, 6 2/3 and 6 2/3 is 12 4/3, right? Which is 13 1/3. But you're right, 13 1/3 is 13.3 repeating. You see how I made that transition? Okay, sorry about that. And now I can get to 100. So what Soham's mistake was, and what I fell right into, is he was getting the total to be 100, because that's what I had just done, but now we're trying to get the percent to be 100. So now I have to multiply by 10. So it's 133.3 repeating. Do you get that? Really? So in money, we don't have repeating. Once we talk about money, we stop at 2 decimals. Because it doesn't make sense to have repeating decimals in money because we only have pennies. Does that make sense? Okay. So what you guys are going to do today in class for a little bit of time is we have a couple things. You're going to look at problem 3.1 now. And I gave you a lot of background to do that. But this is an opportunity for you to see if it makes sense. And that's on the wrong book. 63. Yeah. And 64. I think you can definitely look at 64. Well, start reading on 63 where it says we covered a lot of the reading, but we didn't really talk about markup. So begin reading at the bottom of page 63, just to read about markup. And then you're going to try problem 3.1. And it should be pretty quick to go through at least 1 through 3 because we've given some background, but you want to keep going. But I think in 10, 12, like 15 minutes, you should definitely be through problem 3.